Quadratic functions in factored form. Application of quadratics in factored form. More specifically, we're going to look at some number problems like the ones we did last year in grade 10. So the first thing we have to remember when we problem solve with quadratics is, what are we looking for? A maximum or a minimum? Or a specific value where we can use the zeros method? Or really where we're using factored form? Either way, we have to introduce variables and create an equation in either factored form if we're looking for the zeros, or in vertex form or factored form if we're looking for a maximum or a minimum. And then if I'm looking for a specific value, I'm going to find the roots of that equation and use the ones that make sense in the context of the problem. For example, I can't have a negative time or negative dimensions. If I'm looking for a maximum or a minimum, if it's vertex form, it's easy. I just pull the y-coordinate of the vertex, and that gives me my maximum. If it's factored form, then I use the midpoint of the zeros, and I can substitute that into the equation to solve for my maximum. Now, the first question I have is talking about the sum of a number and twice its square is 300. Determine the number. I've read my question. Don't forget to grab your trusty highlighter. I need the sum of a number twice its square is 300. Determine the number. So what does all that tell me? It tells me I'm looking for one number. Sum tells me to add. I've got a number, which I'll just call x for now. Twice means multiply by 2. And square means I'm going to take my number and square it. Is means equals, and 300. So I've got a lot of work I can do before I even get down to writing my question. So there's lots of information that tells me the sum of a number and twice its square. I'm only finding one number, so the first thing I need to do is write a let statement. So let x represent the number. I'm adding two things together because of the word sum. I'm adding the number, which is x, and twice its square, which would be 2 times x squared. And is means equals 300. I have a quadratic equation. There's a quadratic term, a linear term, and a constant term. Now, in order to solve that, we've spent the last few days discussing the fact that all the terms need to be on one side of the equal sign and set equal to 0. And then we can attempt to factor it. Now, if I look at my quadratic that I have here, hopefully I realize there isn't a common factor. There are 3 terms. None of them are perfect squares. So it can't be a perfect square trinomial. It's not a simple trinomial because this quadratic term right here has a coefficient of 2. So really what I'm doing is I'm going to use the complex trinomial strategy, and I can use either decomposition or the quote down under method, end quote, to solve for my x. And since that's my method that I prefer, that's what I'm going to look for. So I need two numbers that multiply to be negative 600, which was the product of 2 and negative 300, and have a sum of positive 1. And of course, those two numbers would be negative 24 and positive 25. And when I use this method, I just drop the 2 in front of each bracket. I put AX to start. The problem was we ended up with a multiple of 2 too many, so we divided by 2, or a multiple of A, I guess is the correct way of phrasing it. And I end up with x minus 12 and 2x plus 25 as my two factors. And I can separate them, set them both equal to 0, because either x minus 12 or 2x plus 25 has to equal 0 in order for the quadratic equation to equal 0. And when I solve, I end up with x equals 12, or x equals negative 25 over 12. And I can write a nice therefore statement and say the number has to be 12 or negative 25. If the question was worded differently, if it said the sum of a whole number, or the sum of an integer, or the sum of a natural number, and twice its square was 300, I would have one answer that would be inadmissible. And that would be this answer right here, this x equals negative 25 over 2. And the reason for that is that number is not an integer, it's not a whole number, and it's not a natural number. So again, if I change the question, then that answer would be inadmissible. Okay. Next example we're going to look at. Determine the minimum product of two numbers whose difference is 12, then state the two numbers. So again, I'm going to take out my handy dandy highlighter. Determine the minimum product, two numbers this time, with a difference of 12, and I need to state the two numbers. Now what am I looking for? I want a minimum product. Oh, and I also want the two numbers. I'm asked to find two things. Now, minimum product tells me something interesting. That tells me that I'm looking for the y coordinate of the vertex. And I'm getting tired of writing. It's not working very good for me. So the first thing we need to do is we need, excuse me, sorry guys. The first thing I need to do is write some let statements, and because I have a difference, I always qualify it by making one number the larger number, because that's easier to keep it straight for me when I go back and I'm creating equations. So y is my larger number, x is my smaller number, and since they have a difference of 12, I can create a relationship between the two numbers. If there's a difference of 12, the larger number subtract the smaller number is going to equal 12. So that's where this equation right down here at the bottom comes from. That's just relating the two numbers to each other, but it has nothing so far to do with this minimum product. Now, I can keep track of my numbers by creating a table, which makes life a little bit easier for me to go back and look at things. If I look at that, I don't want to have an x and a y when I'm going backwards and looking for this minimum product. So I want to eliminate one of the variables. So if I rearrange this equation and I move the x from the left side to the right side, by adding x to each side, I can come up with the equation y equals x plus 12, and I can modify my table so it looks like this, where y equals x plus 12. The other relationship that exists between the two variables is talking about the minimum product, and product means multiply. So I've got p equals, and I'm multiplying my two numbers, which are x and y, together. But I also know that y equals x plus 12, so instead of leaving this a y in my equation, I'm going to substitute x plus 12 into it. Now, I have a quadratic function in factored form. And if I think backwards, what am I looking for? Go back again. I want the minimum product. Well, when it's in factored form, it can give me the zeros. It cannot tell me the vertex right away like vertex form would. So I can find my zeros by setting my product equal to 0, and I would end up with two factors. One where x is 0, and the other where x plus 12 is 0. And when I solve, I get two values of x that are 0 and negative 12. I can use them to find the x coordinate of my vertex by adding up the two zeros and dividing by 2. So I can take x equals 0 and x equals negative 2 and divide by 2. So I end up with the x coordinate of my vertex is negative 6. Now the minimum product would be the p coordinate of the vertex. So if I just substitute negative 6 into the equation, everywhere I see x, I can solve for the p coordinate of the vertex, which would represent the minimum product. And I end up with a minimum product of negative 36. And the last thing I need to know is, when do I get my minimum product? So I need to figure out what my two numbers are. And when I plug it into this table I created at the beginning, plug in x equals negative 6 for the smaller number, and into the equation I have for the larger number, I end up with a minimum product of the two numbers being negative 36 when the numbers are 6 and negative 6. And before tomorrow, or before the test at the very latest, you need to do exercise 9, page 16 to 17, number 1, 3, 4, and 7. Good night.